Okay, let's take a look at another mathematical model that's just a little bit more complex. This is going to be an example of a pressure versus volume. And what we've got here is this is the raw data, and when we graph the raw data, that you can see that it's an inverse proportion. It is not a line. So in order to make it a straight line, we had to take our data and take 1 over the volume and graph pressure versus 1 over the volume. And now we have a line. When I calculated the slope and the y-intercept, I only did it for this second graph, not the first one, since it's not a line. So now we want to go ahead and write our mathematical model for this. And starting with the fact that you've got a line, we're going to start with y equals mx plus b. And we're going to change the equation of a line so that it matches our experiment. So now, where the y goes, you put the letter that represents the variable on the y-axis. And so for our experiment with the line, what variable is on the y-axis? And it's pressure. So what would be a good letter for pressure? And how about if we just make it a P? Okay, now we have to go ahead and figure out what the slope is. Now remember, the slope has a number and a unit. So I'm going to put the number down because we've figured that out with our Google Docs. And it's 1.75. And let's leave a little space because this one's a little bit trickier. So I'm going to leave a little space for my parentheses. Remember that the slope has both a number and a unit. And now let's take a look at the variable on the x-axis. And what variable is on the x-axis? And it's volume, but it's volume to the negative first. Are those going to be the same? Is volume and volume to the negative first the same? And the answer is no. Okay, so we have to make sure we include that negative first power. Okay, we look at the y-intercept. It's 0.002. That's effectively 0. So just go ahead and take that out. That's just going to be 0. We're going to include it. So now what we need to do is to finish this off is we need to, here, let me move this up. We need to figure out the unit. Now remember, the unit on the slope, so the unit on our slope is the unit on the y-axis, and the unit on the y-axis is an atmosphere. You probably can't read that because it's kind of small, divided by the unit on the x-axis, and the unit on the x-axis is really 1 over liters. That's what liters to the negative first power means. Well, remember, atmospheres, when it's by itself, it's really atmospheres divided by 1 over liters. So what do you do when you have a fraction over a fraction? And you need to remember to multiply it by the reciprocal. So the reciprocal is going to be liters divided by 1 times liters divided by 1. And you can see these all cancel out so that all we're left with is going to be an atmosphere times a liter. So when I put in my unit, it's going to be an atmosphere times a liter. We need to get to the point where we can simplify. And that's how you're going to do a mathematical model for a variable that's inverted. So now you've got a couple of examples. So go ahead and get started.